Good morning to all. I am Nandini, Assistant Professor Mathematics, Knowledge Institute of Technology. Today, let us discuss the topic matrices. In matrices, first let us see the definition of matrix. A rectangular box containing m number of rows and n number of columns is called matrix, which is written as m cross n matrix. The below are example of matrices. This matrix is containing m number of rows and n number of columns. This is a m cross n matrix. Next, we see some types of matrix. Row and column matrix. A matrix that has a single row is called row matrix. This is an example of row matrix. A matrix that has a single row is called a column matrix. The below example is an example of column matrix. Square matrix. A matrix that has n number of rows and n number of columns is called a square matrix. It is see, a square matrix is nothing but a number of rows and a number of columns are equal. Here, this is an example of a square matrix. It contains a 2 cross 2 matrix. Next, diagonal matrix. In a square matrix, all elements are 0 excepting leading diagonal elements. This is an example of diagonal matrix. Scalar matrix. In a diagonal matrix, if leading diagonal elements are the same, it is called as a scalar matrix. The below is an example of a scalar matrix. So, next we see characteristic equation. A equation modulus of A minus lambda I equal to 0 is said to be a characteristic equation of matrix A. So, eigenvalues. Let us consider capital A be a square matrix. The characteristic equation of A is modulus A minus lambda I equal to 0. The roots of a characteristic equation are called eigenvalues of A. Next we have see the eigenvector. Let capital A be a square matrix if their x is a non-zero vector. Capital X is equal to x1, x2, up to etc. xn. Capital X be a column matrix such that capital Ax equal to lambda x. Then the vector x is called an eigenvector of A corresponding to the eigenvalue lambda. So now we are going to see how to find the eigenvalue and the eigenvector of given matrix. Our matrix is 1, 1, 3, minus 1. Solution. First let us consider capital A be a given matrix. To find a characteristic equation, the characteristic equation of capital A is modulus of A minus lambda I equal to 0. This is nothing but lambda square minus S1 lambda plus S2 equal to 0. Here S1 is equal to sum of main diagonal elements. In our matrix, we have 1 and minus 1 are main diagonal elements. So, S1 is equal to 0. S2 is nothing but modulus of A. So, determine modulus of A is equal to minus 4. Applying this S1 and S2 value in characteristic equation, lambda square minus 0 lambda minus 4 equal to 0. Simplifying this equation, we had lambda is equal to plus or minus 2. We have two eigenvalues. So, we find eigenvector corresponding to eigenvalue. We know capital A minus lambda I into x equal to 0. Capital A is a given matrix minus lambda into I is a unit matrix, x is a column matrix. Here we have 2 cross 2 matrix. So, column matrix is have x1 and x2, 2 entries. So, which is written as 1 minus lambda 1, 3 minus 1 minus lambda into s1, x2 equal to 0. So, first we have find eigenvector corresponding to eigenvalue lambda is equal to -2. Applying this in above equation, we have 3, 1, 3, 1, x1, x2 equal to 0. Multiplying these two matrices, we have two equations. These two equations are the same. So let us consider only one equation, 3x plus x2 equal to 0. That is 3x1 is equal to minus x2, which is equal to x1 divided by 1 equal to x2 divided by minus 3. So capital X1 is equal to 1 minus 3. Next we have find next eigenvector by putting lambda is equal to plus 2 in the above equation. This equation. So this equation lambda is equal to plus 2. We have minus 1, 1, 3, minus 3, x1, x2 equal to 0. Multiplying these two matrices, we have two equations. In first equation, multiplying minus on both sides, we have x1 minus x2 equal to 0. In second equation, divided by 3 on both sides, we have x1 minus x2 equal to 0. These two equations are also same. So let us consider only one equation, which is x1 minus x2 equal to 0. That is x1 equal to x2, which is implies that x1 divided by 1 equal to x2 divided by 1. Finally, we get two eigenvalues and two eigenvectors. Our eigenvalues of a given matrix are plus or minus 2. The eigenvector corresponding to the eigenvalue lambda is equal to minus 2 is x1 is equal to 1 minus 3, and eigenvector corresponding to the eigenvalue lambda is equal to 2 is x2 is equal to x1 and x2. This is a solution of our given matrix. So far, we discussed the definition of matrix and some types of matrices with example. Also, we discussed the methods of finding eigenvalue and eigenvector for the given matrix. I hope these concepts are clear to you all. Thank you.